So here we have Chapter 5, Section 3. This is Part 1. And I'm going to attempt to use the tablet writer to do the notes. Let's hope my graphs get okay. A blank is the graph of a quadratic function. Well, since this section's called Transforming Parabolas, a parabola is the graph of a quadratic function. A transformation, we've done this before, moving it around on the coordinate plane. A transformation will shift or move a graph horizontally, this way, left and right, vertically, up or down, or both. We're going to make a chart and graph. If you recall, your basic is called the parent function. And we saw this with absolute value. We're going to do the same thing. Okay? So notice, there's nothing else here with x squared. It's just x squared. This is the parent function. It would behoove you to memorize these points for the parent function. Here's our XY table. We're going to choose some values. And in fact, we're going to choose 5 values. The values we're going to choose for x are -2, -1, 0, +1, and +2. Folks, when you take a -2 and you substitute it into the function to calculate the y, when you square a negative, it's always positive. Substitute a -2 in for x, you're going to get a +4. Substitute a -1 in for x, you're going to get a +1. Substitute a 0, you get a 0. Substitute a 1, you still get a 1. Substitute a 2, you get a 4. And you should see symmetry right here in the table of values. Graphing the parent function, I guess I'll use green here, is going to be the same points all the time. It's 0, 0. You don't even really need to make a table. If x is 1, 1 squared is 1. If x is 1, 2, 2 squared is 1, 2, 3, 4. You can use the axis of symmetry. 2 units, right? Because this is my vertex, so the y-axis is the axis of symmetry. And I have another point here. Or just say if x is -1, -1 squared is +1. -2, -2 squared is +4. And then we're going to draw as best you can, well, as best as I can on this tablet writer, the smooth curve through the points and make your parabola. Okay, that's the parent function. Now, we want to know what happens to the looks of the equation when we're moving this vertex left or right, up or down, or both, maybe to the right and up. We've seen this before with the absolute values. Let's take a little review. The family of quadratic functions. The parent function. The parent function is going to be, it is y equals x squared. Sometimes you see this as f of x equals x squared. What does the basic parent function equation look like when there's a reflection over the x-axis? Well, just like before, the leader is negative. This flips it upside down. Now, keep in mind, this negative is not grouped with the squaring, elsewise that would be positive. This is negative, and then the base x squared. Stretching. Well, stretching, we knew before that we multiplied it by some value that was larger than 1. That was a stretch. So y equals a times x squared, but your a value had to be bigger than 1 for it to be a stretch. Shrinking, well, your shrink, you had a fraction in the front, but it's still my a, and if it's a fraction, then a has a value somewhere between 0 and 1. Greater than 0 but less than 1 would be my fractions, and giving me my shrink. And then, of course, if I'm flipping over the x-axis and doing a stretch or a shrink, this would be y equals negative ax to the power of 2. Folks, if my a is 1, then there is no stretch or shrink. All right, that would be like this one here. This negative is this negative. This a could be 1, and there's my x squared. Okay, so reflection in the x-axis. We just put the a there in case it's not a 1. All right. Now, you'll be using the parent function to graph this transformed function. It's always beneficial to at least put the points for the parent function. We know 0, 0, 1, 1, 2, 4. Use the axis of symmetry. I'm 2 units here. Axis of symmetry. I'm 2 units here. Now, we could draw or sketch very lightly with pencil, you know, that parabola for the parent function. I'm not hitting this too good. Excuse me. And now I want to use the parent function to figure out what the new graph is. Well, remember, when it's grouped in there inside with x, that was shifting on the x-axis, but not in the direction of the sign, always in the direction opposite the sign. So not to the right one, but in fact to the left one. Okay, my parabola is still opening up because this out here is positive. So I am shifting and taking the vertex and moving it to the left one. And then this here, -3, means move down 3 units. Okay, so I'm going to take the vertex and I'm going to move it to the left one and down 3 units. Now, once I do that, the rest of this just becomes, you know, this is like my new 0, 0. I get that the coordinates of this point is not 0, 0. But remember, we took the vertex here and we shifted it left 1 and down 3. So this point here would be shifted left 1 and down 3. And this point up here would be shifted left 1 and down 1, 2, 3. That would lie right here. Now, if you look at what's going on, you know, I could potentially think of this as 0, 0 and say 1 squared is 1. And from 0, 1, 2 squared is 1, 2, 3, 4. So it's like you're finding your new 0, 0 point. And then we already used this and this. So from the new 0, 0, I could just do x squared. Okay, so this point is 1 unit away from the axis of symmetry. Remember, the axis of symmetry would go through the vertex. So I would have a corresponding point to the left. This point is 2 units away from that axis of symmetry, so its corresponding would be 2 units to the left. And now I can connect these points with a smooth curve and graph my parabola. Okay, so the pink graph is the graph of the parent function, and I will go ahead and get rid of that so you could see what the original was. Okay, so the pink graph is the graph of x minus 1 quantity squared minus 3 without having to make a table. Remember, you should not be making tables for these. You should be thinking of them in terms of A, the parent function, being shifted. All right, let's do some examples. Graph the quadratic functions. Notice this one right here. This, let's pick a color, green. This is the parent function. There are no translations. There is no up, down, left, right. So we're going to graph it. What are the points of the parent function? Well, I've got 0, 0. 1 squared is 1. 2 squared is 4. Axis of symmetry. And connect with a smooth curve to get that U-shaped graph. Okay, so there it is. Parent function. This graph here is the parent function shifted down 5 units. If you said down 5 units, you are correct. So it makes sense to at least the more I practice with these points on the parent function, the easier my thoughts could be here when I'm graphing these parabolas using these transformations. All right, so this again, what did it say? It said move that vertex down 5 and nothing else is going to change. So I used blue. I'm going to say, all right, vertex, you're going to shift 5 units down. That's my new 0, 0. So this is my new 1, 1. And this is my new 2, 1, 2, 3, 4. Axis of symmetry. And draw your smooth curve, your parabola, passing through those points with arrows. Remember, all your graphs need arrows. So if you have any questions on this, which hopefully you don't, hopefully you learned the other stuff pretty well, and this is just all coming back to you. But if you have any questions, you know what to do. You can come to the Google Meet. You can post on the homework discussion. You can ask me in class if you're in class. All right, let's take a look at this one. What's happening with this one? Oh, I'm not going up or down, but in fact, I am traveling left, right. Not in the direction of the sign, in the direction opposite. So I'm going to move the parent function, the vertex of the parent function, to the right 4 units. Okay? Gets moved to the right 4 units. So I'm going to graph the parent function. Here it is, 0, 0, 1, 1, 2, 4. Axis of symmetry. I'm going to choose to do that in this pencil so it's not as dark. You might want to do it light and then with your pencil, or if you have colored pens, make this look a little nicer on your paper. So move this to the right 4 units. So take this vertex, I'm going to use a different color, pink. And take this vertex and move it to the right 4 units. That's my new 0, 0. So this means this is 1, 1. 1, 2, 1, 2, 3, 4. Axis of symmetry. Axis of symmetry, right? It's going to pass right through the vertex. And here is the graph of the parabola shifted 4 units to the right. Okay. Got three more examples. Well, I'm going to start with the parent function again. So maybe I will, with my charcoal, 0, 0, 1, 1, 2, 4, axis of symmetry, and sketch in my parent function. All right. I'm going to pick more colors. All right. I don't want that thick. There we go. All right. So what does this one say to do? This one says, oh, this is upside down. But also moving up 3. So this is a reflection. Okay, this thing right here means reflect, and this means move it up. Right? It's different when it's grouped in with X. This means move it up 3 and then flip the thing upside down. All right, so I'm going to take the vertex and I'm going to slide it up 3 units. Right, there it is. And now I would do my, 1, 1, but I have to be upside down. So I'm going to go 1 upside down 1. And then 1, 2 upside down 1, 2, 3, 4. Axis of symmetry. And connect with a smooth curve. Always give arrows. Okay, so there is the transformed parabola. Shifted up 3 units and then flipped upside down. The next one, let's do parent function. I'm going to do parent function on both of these coordinate planes. 0, 0, 1, 1, 2, 4, axis of symmetry, right? This is 2 units to the left. I mean to the right. I need 2 units to the left. And 1 unit. The more you draw that parent function, it's going to be so automatic. You won't even have to think about it. 0, 0, 1, 1, 2, 4, axis of symmetry. And there are my parent functions for the last 2 problems. Okay, now I'm going to go up here and say, all right, well, what's happening? Oh, it's grouped in with X. So I have to move left 6 units. And then I have to flip it. Right? That's a reflection. That's flipping it upside down. So left 6 units and then shift that parabola upside down. So I'm sliding it over here. This is my new 0, 0. Remember, I got to flip it. So 1 squared is 1, but I have to be upside down. And 1, 2 squared is 4, but upside down. 1, 2, 3, 4. Axis of symmetry. This is going to be off the grid a little bit. That's okay. And so now I'm going to connect my points with a smooth curve and draw my parabola. Don't forget the arrows. One more, that'll be the end of the video. You know what to do. If you have questions, post on the discussion, come into a Google Meet, or ask me in class. This one's not getting upside down at all, right? There's no negative here. But I do have 2 shifting. This one here, you would think it means go left 3, but it doesn't. It means go to the right 3 units. This plus means go up 2 units. So I'm going to take the vertex and shift it to the right 3 units and up 2. So to the right 3 units and up 2 puts me here. I am not upside down. It is not negative out front. So now this is like my new 0, 0. 1 squared is 1. From this, 1, 2 squared is 1, 2, 3, 4. Use the axis of symmetry to find those corresponding points. Draw. Connect with a smooth curve if it lets you. Up, there it is. And that's all we got for this part. You will be having to do some graphs, so make sure you have graph paper. And again, if you have questions, please let me know so I can help you. Have a great day.